Alright, we have learned 3 ways to graph quadratic equations. Tomorrow you will have a quiz. You will need to be able to recognize what form the quadratic equation is in so that then you can graph it appropriately. Then you will need to know how to graph all 3 forms. So our first one is in what form? Standard form. They're just all added together. There's no parentheses there. It has an a, a b, and a c value. The a value is 2, the b is negative 12, and the c is 19. To be able to graph in standard form, your first step is to do x is equal to negative b over 2a. That gives us the x value of our vertex. So that would be negative 12 divided by 2 times 2, which gives us that x is 3. Then we plug that in. If I plug a 3 into the equation, order of operations says I square first, so I get 2 times 9 minus 12 times 3 plus 19. Remember, you can feel free to use a calculator to do all your arithmetic. Just be very careful of parentheses and making sure that you're plugging parentheses in appropriate places. And I get a value of 1. And that first point that we find then is our vertex. So our vertex is at 3, 1, and that's where we get our symmetry line. Then you can choose anything you want to plug in for x and find a y value. A lot of times you might want to plug in 0. If I plug in 0 on this problem, what will I get? 19. It's a little bit of a bummer to try to graph. So it might be easier then in these kind of extreme cases to pick something closer to where your vertex is, and that'll keep your numbers more manageable. So I'm going to choose to plug in x is 2. And again, remember, you can feel free to use your calculator to do your arithmetic. And I get an answer of y equals 3. Our third point is found by symmetry. So I can fold that point across my symmetry line and then connect my dots. Remember, you can use the a value of the equation to help you confirm that your graph is doing the right types of things. A positive a value in this problem tells us that our graph should be facing upward. And an a value of 2 tells us that our graph should be pretty narrow and growing quickly. And that's what we're seeing. That's why we get all the way up to 19 so quickly. The directions on the quiz are going to say that I need to see 3 clear, or I think it says even at least 3 clearly plotted points. So that means don't just give me sketches of what they would look like. We need to actually be finding these points and plotting these points. Questions on that one? Number 2 is in what form? Vertex form. It has a parentheses and they have a squared on them. Okay, it has a parentheses with a squared on them. That is going to be our vertex form. In vertex form, our vertex is at the opposite of the inside, comma the outside. So our vertex is at negative 2, 1. And that's where we get our symmetry. Then you can choose any x value you want to plug in. There's not necessarily an easy thing to plug in. So in standard, it's easy to plug in 0, but sometimes your numbers might get a little bit too far to graph. In vertex form, there's not really an easy thing to plug in. So I usually just pick something that's right next to my vertex. So I'm going to pick x as negative 1. And then I'm going to plug that in. And that gives me 0. Third point by symmetry, folding that across our reflection line, and then connecting our dots. Questions on vertex form? What form is number 3 in?
The last one we did.
The last one we did, which is called intercept form, because it gives us our 2x intercepts instead of giving us our vertex. So in the other two forms, the first thing we find is our vertex. In intercept form, we do not find our vertex first, we find our x-intercepts, which are going to be located at -3 and +1. They are the opposites of the numbers in the parentheses, and they are both x values. They are both x-intercepts. So on my x-axis, I put a point at -3 and put a point at +1. Our symmetry line will be exactly halfway between those. So sometimes you can kind of eyeball it or count it out. Sometimes you might need to think about taking an average of those. So if I do -3 + 1 divided by 2, I get -1. So my symmetry line is -1, and that's the x value of our vertex. To find the y value of our vertex, we plug that into the equation. And that gives me +2. And connect the dots. And again, no matter what form the equation is in, it still has an a value. So like in number 2, that negative hanging out there in the front is an a value. That negative tells us our graph should be facing downward in number 2, and that it should have been like a medium width. Number 1 is just kind of considered normal, so not really wide, not really narrow. In number 3, our a value is, I made a mistake, because our a value is 1/2, which tells me my graph should be facing which way? Up. So I lost a negative in here. My vertex is actually supposed to be at -2, which matches better with our a value, making this thing point upward like our a value tells us. Okay. So use those a values to your advantage. I would like to say I did that to just prove a point, but I'll admit I actually just made a mistake and lost a negative. But they can help you out with that kind of thing if you use those a values to your advantage and confirm that your graph is doing what it's supposed to be doing. Number 4 is in what form? Standard, because it's all just added together with no parentheses, and it's also an inequality. We're still going to graph according to standard form the same way that we did in question number 1, but in the end we're going to need to consider either a dotted or solid line and shading for the parabola. So in standard form, our first step is x equals -b over 2a, or -4 over 2 times 1. Which gives us x is 2. Then we plug that in. And I get -1. My vertex is located at 2, -1. And that has our line of symmetry. Then you pick any x value you want. 0 is the easiest thing to plug in when it doesn't give you ridiculously large or small numbers. What does 0 give us this time? 3. It's the easiest to plug in because it'll always just give you that c value. We can fold that point across the symmetry line. And then now is where the fact that this is an inequality rather than an equation begins to matter. This problem needs a dotted line because there's no equal to bar. And then I need to test a point. I like to test the point 0, 0. So I'm going to plug a 0 in for x and a 0 in for y. And that gives me 0 is less than 3. Which is true. Which means I want to shade 0, 0, which is on the outside of this thing. It means I'm going to shade everything on the outside of it. Questions?
Oh. Ah.
What form is number 5 in? Standard form. It is actually exactly the same one. It just has an equal sign. So the line is going to look exactly the same. We're just not going to dot it and shade it. So we'll move on. I don't know why I put the same problem on here twice. Number 6 is what form? Vertex form. Where is the vertex going to be? 3, 2. Opposite of inside, come outside. Then you pick anything you want for your x value. I usually try to pick something close to my vertex, so I'm going to pick 4. And I plug that in, and I get 3. Fold that over our reflection line and connect the dots. Questions?
Can you do number 5?
It's exactly the same problem as number 4. So the curve is going to look exactly the same, you just don't shade it. It's all the same numbers as number 4. So that's why I skipped it. Great. Any questions before I scroll the page up? So when I scroll it up, I lose all the markings and I can't get it back. All right, number 7 is in what form?
Intercept form.
Intercept form. The 2 sets of parentheses and no parentheses squared means that this is going to be intercept form, which means that the opposites of the numbers in the parentheses give us our x-intercepts. So x is 2 and x is 4 are both points on our x-axis. Then our vertex should be right in the middle of those. So what's in the middle of 2 and 4? 3. Then we plug that into the original equation. And I get positive 2. And connect the dots.
So some of that's gonna be it all. Or are we gonna have a choice between which one of these?
this is how the test will be, that there will be some of each form, and you have to do a question appropriate to the form that is written in. Number 8 is what form? Standard form. So for standard form, we do x equals negative b over 2a. Negative 4 over 2 times negative 1. Which gives negative 2. And plug that in. Be very careful with parentheses when you plug it in. We get positive 1. So my vertex is at negative 2, 1. And that's where we have symmetry. Pick any x value you want. If I pick x as 0, what do I get?
3.
Negative 3. And fold it over. I can use my a value to confirm that this thing is going to be doing the right thing. I have a negative 1 a value, so it's facing downward. And it looks like it's just kind of going to be a normal width. Not really wide, not really skinny. So that's a good thing. The equal to bar means that when I connect these dots, I'm going to do so with a solid line. Then I want to test a point. If I test the point 0, 0, I get 0 is less than or equal to negative 3. That is false. So that means I want to shade inside of this thing. I don't want to shade 0, 0.
Is there gonna be questions that are like, we have to label which are standard form or which?
There's one question at the beginning, well I guess kind of 3 questions at the beginning that ask you to identify whether a problem is in standard form, vertex, or intercept form. So you need to know the names of the forms and what they look like. But then all the rest of the questions are going to be exactly like this, where you just have to look at it and know what form it's in to know which way to solve it.
Standard, vertex, and
Standard, vertex, and intercept are their names. Right. We've done a couple of examples of every form now. So with 9 through 12, there is one more example of each type. So your task is through the end of the class to go ahead and complete those out, and then I'll have an answer key that you can check your answers with.